Canonical Transformation and Poisson's bracket. Canonical Transformations and Poisson's brackets will have two parts. The canonical transformation is one part, and the Poisson's bracket is another part. So, in the last chapter, you just look at the conditions, that is, the Lagrangian and the Hamiltonian formulation. So, we'll just have to look at the equations of motion. So, in order to look at the equations of motion, we'll just have an idea that this equation that trying to becomes more singular. ठीक है? आपल्याला उद्देश काय होता किंवा what is our point? The point is that we have to make the solution that are quite simple. But while you are solving this Hamiltonian and Lagrangian equations, you just realize that these are not at all that much of simple. Okay? एवढे काही असं सोपे नाही आहे. So for that, let us say we just consider the conditions or a case in which all the coordinates are nothing but cyclic. काय करायचं आहे की जेवढे काही कोऑर्डिनेट्स आहेत ते सगळे कोऑर्डिनेट्स जर आपण असं समजलं कुठले कोऑर्डिनेट्स लेट अस से qr. Suppose these all the coordinates qr are nothing but cyclic, and so that the Hamiltonian is constant for such conditions, then the conjugate momenta bi is constant. Condition सगळे लक्षात आहे का? We'll have a condition that is gamma L by gamma qi dot is equal to this pi. Okay, and that must be something constant. When it is possible? When it is possible when this qi is nothing but a cyclic coordinate. सगळे लक्षात आहे. We'll have an equations for the Lagrangian, that is gamma d by dt of gamma L by gamma qi dot minus gamma L by gamma qi, that is equal to 0. So that is our equation. So when this Lagrangian that is equal to 0 by this factor, then we will have a condition that is ddt of gamma L by gamma qi dot is equal to 0. When it is possible, when this is a cyclic coordinate or ignorable coordinate. Okay, so gamma L by gamma qi dot is equal to pi and that is equal to constant. So that is possible only if this conjugate moment is the constant, and so that these problems can be solved. So we will have that conditions. Now what we have to do? The situation where this qi, okay, this qi that means the cyclic coordinates is somehow the situation that should be, you can say, like all the coordinates are cyclic. Condition सगळे लक्षात द्यायचे. If the situation is like this, there are large number of coordinates. So we'll have a point that is say q1, q2 up to qn, and qi is somewhere here. So we are considering the case only where this qi is constant, then we can have that pi is constant. Now let us suppose this all the coordinates, okay, these are nothing but the cyclic, so that we can solve this problem more easily. But it never happens that this all the coordinates, जेवढे काही coordinates आपण सांगितले ते सगळेच्या सगळे cyclic असतील असं खूप रेअर केस मध्ये घडतं. मग अशा वेळेस काय करावं लागतं? we'll have to solve this with the help of a set of new coordinates. कंडिशन काय सांगायची लक्षात येईल का पहा. जर एखादा कोऑर्डिनेट सायक्लिक असेल तर जस्ट से दिस इज कॉन्स्टंट. ठीक आहे, मग तो आपल्याला काही प्रॉब्लेम आहे तो सॉल्व करता येतो. परंतु हा प्रॉब्लेम आपण जे हॅमिल्टोनियन वगैरे कॅल्क्युलेट करतोय तर त्याच्यामध्ये काही कॅल्क्युलेशन्स इन्व्हॉल्व आहेत. हा कधी सोपे होईल किंवा हा कधी इझी होईल ज्या वेळेस हे सगळेच्या सगळे जे काही कोऑर्डिनेट्स आहेत q1 q2 qi अप टू qn हे सगळेच्या सगळे सायक्लिक असतील, त्यावेळेस सगळे जे काही मोमेंट असतील ते काय असतील? कॉन्स्टंट असतील, आणि त्यावेळेस आपल्याला हा प्रॉब्लेम जो आहे तो इझिली सॉल्व करता येईल. वन थिंग, बट The condition is that ही जी काही coordinates आपण म्हटले जनरलाइज coordinate हे सगळेच एकाच पॉइंट ऑफ टाइमला इग्नोरेबल असू शकत नाही किंवा सायक्लिक असू शकत नाही. ही खूप रेअर कंडिशन एखादी असेल की ज्याच्यामध्ये सगळेच इग्नोरेबल आहे किंवा सायक्लिक आहे. बट दिस हॅपन्स व्हेरी रेअर. मग अशा वेळेस काय करावं लागतं? अशा वेळेस आपल्याला हे जे काही कोऑर्डिनेट्स आहेत दिस कोऑर्डिनेट आर विल चेंज फ्रॉम समवॉट ओल्ड कोऑर्डिनेट सिस्टम टू से a new coordinate system, and that's why we'll have to do a transformation. Okay, and that's why this is known as a canonical transformation. So what is the conditions for this canonical transformation? So canonical transformation is nothing but the transformation of an old coordinates, that means the old position coordinate, the old position coordinate qy and the old momenta, that is nothing but, let us say this is pi. Okay, so we have to transform the old position coordinate qy and the old momenta pi to the new coordinates, that is new position, which is known as capital qi and new momenta, that is momentum, that is nothing but capital pi. Symbol मध्ये फरक लक्षात घ्या. Small qi pi, these are nothing but old coordinates, and new, that is nothing but capital pi and capital qi. So these are nothing but the transformation of old coordinates to the new coordinate, and that is known as the canonical transformations. So due to the transformation, we'll have a set of coordinates, that means our Hamiltonian, that we can change from your old coordinate, that is h of this qi, pi, t, to the new set of coordinates, that is known as k, and that is given as k of, this is nothing but capital qi, this capital pi and small t. What is t? That is called as the time. So this is known as the transformation of old Hamiltonian to the new Hamiltonian. This is known as Hamiltonian, and this is transformed to a new Hamiltonian k, which is known as Canonical. सगळ्यांनी लक्षात येते का बा? आपल्याला आता ट्रान्सफॉर्मेशन करायचंय, आणि ट्रान्सफॉर्मेशन करताना काय लक्षात ठेवायचं आहे? सो वी आर ट्रान्सफॉर्मिंग आवर ओल्ड पोझिशन अँड मोमेंटा टू द न्यू पोझिशन अँड मोमेंटा. Okay, so the position is qi, so it is transferred to capital qi. The momenta is pi, small pi, and this is transferred to a new pi, that is capital pi, that is nothing but new momenta. So our old Hamiltonian h of qi, pi, t, that is transferred to k, that is called as Hamiltonian of capital qi, capital pi and t. सगळ्यांनी लक्ष देत आहे. आता आपल्याला ट्रान्सफॉर्मेशन करायचे की ज्याला आपण म्हणतो कॅनोनिकल ट्रान्सफॉर्मेशन, आणि हे कॅनोनिकल ट्रान्सफॉर्मेशन्स या पद्धतीने असते. सो दिस ट्रान्सफॉर्मेशन ऑफ qp, this transformation of small qp to old capital new capital Q capital P, symbol small q small p to capital Q capital P is canonical. Okay, this is said to be canonical if and only if they will satisfy the canonical equations. कुठले canonical equations होते? तर आपल्याकडे canonical equations होते बा, that is qi dot is equal to gamma h by gamma pi. हे आपलं एक इक्वेशन होतं canonical. दुसरं एक इक्वेशन होतं आपलं, that is this pi dot is equal to minus gamma h by gamma qi. हे दोन canonical equations होते. तीसरे इक्वेशन होतं gamma h by gamma t is equal to gamma h by gamma t. But we are not considering here the Lagrangian, so we have just required these two equations, that is qi dot is equal to gamma h by gamma pi small, and that is gamma pi dot is equal to minus dabba L by dabba ky. This is for your old Hamiltonian. If this transformation is said to be canonical, then this new Hamiltonian, that is known as Hamiltonian, that must satisfy the equation, and that equation I have a form that is nothing but this qi dot, okay, qi dot, small qi dot is equal to dabba L by dabba pi. Now new qi dot, that is new position, that gives us dabba k by dabba capital Pi. Qi dot is equal to dabba k by dabba pi, and this pi dot in terms of nu, that is capital Pi dot is equal to minus dabba k by dabba qi. सगळ्यांनी लक्षात येत आहे. So this transformation qp, small qp, old coordinate to the new position and momenta coordinate, they are said to be canonical if, okay, or you can say such that they must satisfy this condition. Okay? If they satisfy this, then it is said to be a Canonical transformation. आपल्याकडे Hamiltonian होतं का? We are using a Hamiltonian equation, that is h is equal to summation over I, that is qi dot, then this pi minus L. H is equal to summation over I qi dot pi minus L, or qj dot pj minus L, that is our Hamiltonian. So what should be the new Hamiltonian? That is Hamiltonian. So that Hamiltonian, that can be written as k is equal to summation. So this is capital Qi dot into capital Pi minus the Lagrangian, and that Lagrangian is nothing but L dash. सगळ्यांनी लक्षात येते का पहा, Lagrangian तोच घेतलेला नाही. Lagrangian is changed L to L dash. So we can have that coordinates old कुठले आहेत आणि न्यू कुठले आहेत हे लक्षामध्ये ठेवा. एकच फॅक्टर कॉमन आहे, and that factor is nothing but time. ठीक आहे, जो ओल्ड मध्ये पण टाइमच आहे, न्यू मध्ये पण टाइम आहे, that is not changed. So what is changed? The change can be seen like this: old position momenta to the new position momenta, and we can have old Hamiltonian to the new Hamiltonian, which is known as Canonical. Also the Hamiltonian equation is changed from summation over I qi dot pi minus L to Canonical, k is equal to summation over qi dot pi minus L dash. So we can have these transformation equations, and that can be get correct, okay, when we'll substitute the value of L dash in the Hamilton's principle. So what is the Hamilton's principle? The Hamilton's principle is delta this L dash dt, that must be equal to 0. So you can have that condition. This Hamiltonian is having this value, and this L dash value that must be substituted in the Hamilton's principle, that is delta integration over L dash dt, okay, that must be 0, and that gives a correct equation of motion. ठीक है, जर हे satisfy होत असेल, delta integration L dash dt is equal to 0 येत असते, तर आणि तरच एक Hamiltonian जे आहे, that gives us a correct equation of motion, or you can just say that gives a equation in terms of these new coordinates, that is nothing but qi and pi. So that is our condition. सगळ्यांनी लक्षात येते का पहा, canonical transformation म्हणजे काय? तर canonical transform म्हणजे transformation of old coordinate to the new coordinate. ठीक आहे, that is nothing but your condition. मग Hamiltonian आपण h of qi pi t तो चेंज केला to the Canonical, that is capital qi capital pi आणि t. मग याच्यामध्ये जे काही ट्रान्सफॉर्मेशन इक्वेशन्स आहेत, जे काही हॅमिल्टोनियनचे इक्वेशन्स आहेत, तेच इक्वेशन्स कॅमिल्टोनियन देखील फॉलो करेल. जर हे असं असेल तर आपल्याला हॅमिल्टोनियनचे जे काही इक्वेशन आहे ते we can write that in terms of Hamiltonian. We can have that condition that it must follow this Hamilton's principle, that is delta integration of L dash dt, and that must be equal to 0. So this gives us the equation of motion in terms of the new coordinates, that is qi and pi. So this is the first thing, that is we have to change the coordinates. We will have to use these conditions in the to find out the generating functions. Now the second point is the canonical transformation that can be preserved the Hamilton's canonical equation of motion. And how this can be get preserved? This can be get preserved by the values, that means we can have this value of Qi, that Qi value that is equal to this Q1, Q2 up to Qn. Then it is depends upon P1, P2 up to Pn and time. As well we have a capital momenta, that is new momenta Pi, that is equal to this Pi is equal to Pi of, we'll have that value, it also depends upon the generalized coordinates, the generalized momenta and time. Okay, so just say this old and new coordinates and position and momenta, or new position and momenta that are related to the old position and momenta likewise. Okay, so you'll have to just look at these points, how they are related. So this Qi that depends upon this old position coordinates and old momenta, as well as this new momenta that also depends upon this old position and old momenta, as well as the time. Time is the main factor. So we'll have to look at the next point, that is nothing but the transformation. आता आपण म्हणतो आहे की ट्रान्सफॉर्मेशन करायचे ओल्ड कोऑर्डिनेट टू न्यू कोऑर्डिनेट, but how this transformation can be done, that we'll have to look. So just we are just transforming this from old coordinate to new coordinate. Okay, and for that we'll have to change the basis. Okay, we'll have to change the set of coordinates, and that set of coordinates, that is nothing but this Legendre transformation. So this Legendre transformation is a technique which is used to change the basis from one set of coordinate to the another set of coordinates. So just remember these points. Now we'll have to look at that, how this Legendre transformation that works. Let us say we'll have an equation that is function f, which is equal to f is equal to f of xy. So that f that depends upon the two independent variables x and y, and such that we can have a total differentiation. जे आपण already calculate केलेले आहे मागच्या वर्षी. So the total differentiation that is given as df is equal to dA by x into dx plus dA f by dA y into dy. Okay, so let's also write this equation df as u dx plus v dy. So what is u? U is nothing but dA by dA x, and what is v? That is nothing but dA by dA y. So we'll have these equations. Okay, जे काही टोटल डिफरेंशिएशन आहे ते टोटल डिफरेंशिएशन आपण या पद्धतीने लिहू शकतो u dx plus v dy. So we'll have that one point. So just say this is our one equation. Now what we'll have to consider? Now we'll have to consider, that is we'll have to change the basis from xy to uv. काय केले xy पासून uv पर्यंत आलं. So we can just write that u is equal to dA by dA x, v is equal to dA by dA y. Now we have to change this basis from what? We have to change this from xy to uv. What is Legendre transformation? That is the change of basis. So we are changing the basis from xy to uv. Let us say u is an independent variable and x is the dependent variable. Okay, now just consider the things. We will have to change the basis in such a way that this u is considered to be an independent and this x is considered to be a dependent. Okay, such that we can have a function, let us say f dash, and that f dash function that depends upon these two variables. Which one? That is u and y. Consideration काय केले पहा. We'll have to transform, we'll have to change the basis from xy to uv. Is it changed in such a way that u is the dependent variable and x is the independent variable, and we'll have to define the function f dash in such a way that this f dash is equal to f dash of uy. Okay, and this is such that this can be done in the condition such that this f dash value is equal to f dash is equal to f minus ux. Conditions for just do not get confused. So you have that point f dash is equal to f dash of uy, and this is in terms of a condition such that f dash is equal to f minus ux. Okay, so you just differentiate this one, and we can write that is df dash is equal to df minus, we have two values, so this is u dx minus x du. Okay, so you'll have a value of df here, so you will just use this equation. Okay, I'll number this. You just use equation number 1, and we can write this df dash is equal to df, that is nothing but u dx plus this v dy minus this u dx minus x du. So this u dx that will get cancelled out, and we will have a value that is df dash is equal to v dy minus x du. So just say this is nothing but equation number 3. Okay. Now what we'll have to do, we'll have to just look at the point. So we'll have a point that is this function f dash is equal to f dash of u1. Okay, what is our condition? We have defined that f dash is equal to f dash of u1. We'll just have total differentiation, and we can write that df dash is equal to gamma f dash by gamma u into du, okay, plus gamma f dash by gamma y into dy. So let us say this is the equation number 4. इथं आपण दोन इक्वेशन्स काढले होते. We have that f and we have a total differentiation. Now we have that f dash and we have a total differentiation. Now we have two equations for your df dash, that is df dash is equal to v dy minus x cube, and df dash is equal to gamma f dash by gamma u into du plus gamma f dash by gamma y into dy. So we'll just compare this, and by comparing we'll just compare the coefficient of dy, and we'll get the first value of v is equal to gamma f dash by gamma y. Okay, first thing. And the second thing is we'll have a coefficient that is du, so the x is equal to minus gamma f dash by gamma u. So we'll have two values. Okay, we'll have a value of v is equal to gamma f dash by gamma y, and x that is gamma f dash by gamma u with a negative sign. लक्षात घ्या काय सांगितलं होतं, we are just transforming the equation and changing the basis from xy to uv. Okay, so that u is a independent variable and x is the dependent variable. u independent है, x dependent है, आणि हे कसं consideration केलं होतं, let f dash is a function of u1, and that is such that f dash is equal to f dash is equal to f minus ux. So you have that df dash, we just compare, we just use the value of your df there, and we can have equation that is df dash is equal to v dy minus x du. And so we have changed the basis from, just look at x to u and v to y. सगळ्यांच्या लक्षात येतं की बेसिस कसं चेंज केलेलं आहे, कशा पद्धतीने सेट कसं चेंज केलेला आहे ते आता आपल्या याच्यामध्ये लक्षात येईल. So by just comparing this, we'll get these two values. V is equal to gamma f dash by gamma 1, and x is equal to minus gamma f dash by dabba u. And this transformation equations ही जे काही आपण x आणि v च्या व्हॅल्यू कॅल्क्युलेट केलेल्या आहे याला काय म्हणतात आहे दिस इज नोन ॲज the Legendre transformation equation. Okay, this transformation from xy to uv, that means these equations v and x, these are known as the Legendre transformation equations. कंडिशन एकदम सोपी आहे. आपण sy ला जे काही सगळ्या गोष्टी पाहिल्या त्याच पद्धतीने या so we'll have this function total differentiation and just use the condition. ज्या काही कंडिशन्स आपण डिफाइन केलेल्या आहेत त्या फक्त यूज करा and you get the equations. The next point is we'll have to look at the generating function. Generating function देखील आपल्याला याच्यामध्ये पाहायचं आहे. So we'll just look at that generating function. What does it mean? It means that now we'll have to look at the actual functions. How these functions they will look like. We'll have to find their equations and how these functions that will depends upon this old coordinate and the new coordinates. We'll look at this. You remember these points that we'll have to use in order to find out these generating functions. Now we'll have a transformation equations. दोन equations आपण पाहिलेले होते. Now we'll have to use the Hamilton's principle. If you remember that the principle is like this: integration delta L dash dt that must be equal to 0 and that is from a time from t1 to t2. That is your Hamilton's principle. Now we have to use the two conditions. One is the old Lagrangian and another one is the new Lagrangian. So old Lagrangian is like this, that is it depends upon L of this Qi, okay, and your momenta. Now we'll have that points, then L dash will have just let us say your it is related to the new coordinates, old coordinates Qi, Pi, and this new Lagrangian that is related to capital Q1 and capital Pi. So we'll have that point. Okay, and this we'll have to use in order to have a conditions. How this can be used? So we'll have a Lagrangian equation. आपल्याकडे Hamiltonian equation होतं बा. That is nothing but this Qi dot Pi minus L. Okay, so I'll just change it and I can write this L is equal to summation over this Qi dot Pi minus H, first thing. The second thing is that we'll have a Canonical equation, that is summation over this Qi dot and this capital Pi minus L dash. Now we'll have a new Lagrangian, that is L dash is equal to summation this Qi dot into capital Pi minus this thing. So we'll have two equations, okay, L and L dash. This is in terms of Pi Qi, okay, and now the second one L dash in terms of Qi Pi. So we'll just use this Lagrangian, okay, L in old coordinate. So in terms of old coordinate, we'll have a Hamiltonian principle, that is delta integration L dt is equal to 0, that is limit from t1 to t2, or that can be written as delta integration the value of L, that is nothing but the summation Qi dot small into pi minus h into dt, and that is equal to 0. The Lagrangian L dash in a new coordinates, okay, so we'll have that in terms of new coordinates. How we can write that? We can write that delta integration from t1 to t2, this L dash dt, that is equal to 0. What does this mean? This means that we have a Hamiltonian principle, that is delta integration. This is given in terms of summation capital Qi dot into capital Pi minus k into this dt, and that is equal to 0. सगळ्यांच्या लक्षात येते का पहा? हॅमिल्टोनियन प्रिन्सिपल आहे डेल्टा L dt is equal to 0, डेल्टा L dash dt is equal to 0, डेल्टा इंटिग्रेशन L dash dt is equal to 0. आपण काय केलंय? आपण फक्त याचे काही व्हॅल्यूज आपण L आणि L dash चे कॅल्क्युलेट केले होते फ्रॉम ओल्ड हॅमिल्टोनियन आणि न्यू हॅमिल्टोनियन, त्या फक्त याच्यामध्ये पुट केल्या. And by putting these values we will get these new equations. Okay, so you can have the two conditions. So delta integration Qi dot Pi minus h dt is equal to 0, and delta summation integration summation over Qi dot capital Qi dot Pi minus k into dt is equal to 0. Now what is the condition? Now the coordinate this Qi and Pi, लक्षात घ्या, the coordinates, that is new coordinates Qi and Pi, these are said to be canonical. Okay, हे जे काही coordinates आहेत capital Qi and capital Pi यांना canonical म्हणायचं कधी? When this will get transformed this condition, म्हणजे काय? When this capital Qi will get transformed to this small qi, or this capital Pi that get transformed to small pi. ट्रान्सफॉर्मेशन कधी बनायचं? ज्या वेळेस हे कॅपिटल Qi टू स्मॉल qi किंवा स्मॉल qi टू कॅपिटल Qi and स्मॉल pi टू कॅपिटल Pi होईल, त्यावेळेस त्याला म्हणायचं आहे canonical transformation. So in order to have that canonical transformation, we'll just have that two equations, and these two equations that can be written like this. Now the point is, we'll just subtract this second equation from this first one. So what we'll get? We'll get the equation that is delta integration. So we'll have a first, that is summation over small Qi dot Pi minus h. Okay, that must get subtracted from this equation. That is, we'll have that subtraction of capital Qi dot capital Pi minus k into dt, and that is equal to 0. So we'll have a limit from t1 to t2. So if we can have this point, we can have an equation. Okay, so just that this is the equation number 1. Now what we'll have to do? Now we'll have to look at a delta variation process. As while asthana तुम्ही हे delta variations पाहिलं असेल. So we'll have that delta variation process. So how it will looks? This delta variation process that can be, that is this L dt, that is equal to 0, that can be given as in terms of a function. Okay, so हे जे काही function आहे ते function आपण या पद्धतीने लिहू शकतो, किंवा जे काही delta variation process आहे ती actually या पद्धतीने लिहिली जाते. So delta integration is f dt, that must be equal to 0. What is f? F is a function, and this function that can be generally given in terms of conditions, that is this f is equal to df by dt. हे जे काही function आहे ते function बऱ्याच वेळा याही फॉर्म मध्ये दिलं जातं, f is equal to df by dt, and so we'll have that conditions, that is this function that can be chosen in terms of df by dt, and that is known as an arbitrary function. So what we can write? So we can write this delta, that is integration df by dt into this dt, that must be equal to 0. Let us say this is nothing but your equation number 2. काय करतोय? We are using a delta variation process. If there is a small change, so that delta variation process that can be given like this. F is a function. So this function generally can be defined in this way: f is equal to df by dt. We just put that value here, and we can have delta integration df by dt is equal to 0. So just check it out for these two equations. We'll have that two equations. This is also a delta variation process. This is also a delta variation process. So by comparing these two equations, what we'll get? We'll get an equation that is this df by dt. Okay, that df by dt is equal to this. That is summation over I. This qi dot into this pi minus h minus this summation over I, this qi dot capital into this capital pi minus k. Function क्या है? तो function कशा पद्धतीने लिहिता येत आहे? That is called as df by dt, and that df by dt is written in this way. Or we can write the conditions, that is our final thing that can be given as, that is summation over I, this small qi dot pi, okay, minus h, that can be written as, just check it out, this is summation over I, capital qi dot into capital pi minus k plus this df by dt. Summation over qi dot pi minus h, in term ji आहे ट्रांसफर करून दिले. So we'll have that summation over I qi dot pi minus k plus df by dt. So this function, okay, it is known as a generating functions. So we'll have to find these conditions. हे जे काही फंक्शन आपण लिहिलेलं आहे, ठीक आहे, इथे जे काही फंक्शन आहे, दिस इज ऍक्च्युअली अन आर्बिट्ररी फंक्शन. आर्बिट्ररी कशासाठी म्हणायचं आहे? कारण आपल्याकडे चार कोऑर्डिनेट्स आहेत. कुठले कुठले? ऍक्च्युअली 5 कोऑर्डिनेट्स आहेत. स्मॉल qi, capital qi, small pi, capital pi, and the last one is the time. So we'll have that 5 coordinates. So depending upon that set, we'll have a different generating function. So remember that we have this equation, that is summation over I qi dot pi minus h is equal to summation over I capital qi dot pi minus k plus df by dt. Now this function is having a set of 2n plus 1 variables. हे जे काही फंक्शन आपण लिहिलं आहे याच्यामध्ये किती व्हेरिएबल्स आहेत? याच्यामध्ये 2n plus 1 व्हेरिएबल्स. ऍक्च्युअली